The Monty Hall problem is a very counterintuitive statistical problem. So that's why people have interest about it. So we'll discuss it today. The problem is very straightforward. Okay, so let's say we have three containers. Okay, this is 1, this is 2, this is 3. Okay, so what we know is there is in one of those containers has a treasure inside. I use $ to represent it. Okay, let's say $100, $1,000, or whatever, something valuable. Okay, but the container is black and not clear. You cannot see the inside, so you don't know the treasure is in which one. You have no idea about it. Okay, so what you can do is you randomly pick one. Good luck. Okay, you bet on one. This one, or this one, or this one. So I use the arrow to represent the one you pick, random one. Now, once you make your decision, I'll do a favor for you, and I open one of the empty container. Okay, let's say this one. Okay, I open it, and tell you that this one's empty. Okay, then I ask you whether you want to make another second decision. You want to switch or you stick with your original choice. Okay, this is a question. Should you stick or switch? Okay, if you already know the answer, I may provide what I think. Okay, maybe a different solution for you. If you don't know the answer, you may pause the video and think about it, because it's a good time to challenge your mind. Okay, this should be the easiest solution I can think about it. So it's very intuitive. Okay, so in the question we know that there are three containers. They are all black. You know, we cannot see the inside of it. Okay, but we know there is a treasure in one of them, but we don't know which one. Okay, now what I want to do is, let's do one more thing. So let's see, you pick this one. Okay, you pick this. This is one that you choose. Okay, I'll do one more thing and put the other two into a black box. And cover it. Okay, you won't see what happened in this one, in this black box. It's a black box. Okay, anything can happen inside it. Okay, you know, you won't see what happened. Now, I ask you one question. So what's the possibility or probability for you to win if you choose one? Tell me. Okay, so if you have a little bit of sense of statistic, you would know that, okay, there are only 3 boards. Okay, only 3 containers. Okay, I only pick one, and the other 2 are in the black box. So, you know, ideally, or suppose, you know, very common sense, you know, I should have 1/3 of a chance to win. And the black box, what's the possibility for the black box to win? 2/3, right? Should be, because, you know, sum up together, this should equal 1. So, you know, 100%, you cannot go over 100%, right? Okay, now, this should be the step 1. Should be the step 1 for us, you know, for our solution. Now, step 2. Let's think about it this way. I just make a copy of a step 1. Okay? Now, what I'm gonna do is, because this is a black box, right? Black box, you don't know what happened inside. I'm gonna add in another container, and it's empty. I'm gonna add this empty container into this black box. Okay, now you tell me, what's the probability of you to win? Still 1/3, right? Still 1/3, because I add in the empty container to the black box. Nothing changed, correct? What's the probability for the black box to win? Still 2/3, because I added empty container into the black box. We don't know what happened in this black box. Okay, now I'm gonna do one more thing. I add another black container, empty container into this black box. Another empty container to this box. Another. Now, how many I can add? I can add so many, right? During this process, I keep asking you the same question. what's the probability for you to win if you stick with your original choice? 1/3. Nothing changed, right? Okay, what's the probability for this black box to win? Remember, I keep adding empty container into this black box. Still 2/3. Nothing changed because all the containers I add in empty, correct? Now, here's the interesting thing gonna happen. The step 3, we're gonna find the solution in step 3. Okay, so I move down a little bit. What I'm gonna do is I'm gonna make a copy of step 2. So you can see we step by step. Okay. Here. Now, this is our step 3. Okay. What I'm gonna do different from step 2 is I'm gonna remove empty containers from this black box. I remove one. Tell me, what's the probability for you to win in, for your original pick? Okay? Because I removed the empty container from the black box. How do you think? Still 1/3. Nothing changed, correct? Because what I'm gonna remove is the empty container. So what's the probability for this black box to win? 2/3. Because I add in an empty container and also removed an empty container, right? Now, let's keep doing it, just like the step 2. Okay, we keep adding container. Now, in step 3, we keep removing empty container. Remove another one, remove another one, remove another one, remove another one, remove another one. Tell me, what's the probability now for you to win if you stick with your original pick? 1/3. Anything change? Nothing. Nothing changed, correct? Now, what's the probability for this black box to win? Because I add in all the empty containers in the second step, and then remove all those empty containers in the third step. Anything change? Nothing changed. The probability for the black box to win is still 2/3. Now I'm gonna do one more thing and remove an empty container in this original 2 containers. Tell me, what's the probability for you to win? Still 1/3 and still 2/3, because no matter how many empty containers we add into the black box, or no matter how many black containers we removed from the black box, it won't change the probability. So now here comes the solution. If you stick with your original choice, you only have 1/3 of a chance to win. If you switch, you will have 2/3 of a chance to win. Should you stick or should you switch? Okay, so the answer should be you should switch. You got it? Now let's take a look at another solution, second solution. Okay, now let's suppose we have one treasure in one of box. Let's say this box is number 2. Okay, so and what do you pick? You pick number 1. Okay, or you can have the second. You can pick number 2. So, okay, this is what the container treasure in, or you have your own choice for the third container. So how many options there? There are 3, because there are only 3 containers. Correct? Let's see. The treasure is in the second container. Okay, like what we write in here. So if the treasure in the second container and your choice is the first container, okay, what container can I open? I only have one choice. I can only open this one. Okay, I can only open this one. Now I ask you, should you stick or should you switch? let's say if you stick, you lose. If you switch, you win. Right? Gotcha. So now let's say if your choice is the second container. Okay. Now what I can open, I can open either one, this one or this one. Let's say I open this one. I tell you this one's empty, and I ask you whether you want to stick with your choice or whether you want to switch. Now it's very clear there, right? If you stick, you win. If you switch, okay, you lose, right? Okay, now let's discuss the third, your third option. The treasure is still in the second container, right? And you pick the third container. Now, what container can I open? I can only open this one because I cannot open this one. This one has treasure inside, right? Now I ask you whether you want to stick or you switch. You can tell that if you stick, you lose. Okay, if you switch, you win. Now let's do just to sum up the probabilities. Okay. Now, we can clearly see that, you know, we have only 1 out of 3 to win if we stick, and we have two times to win out of 3 if we switch. So the possibility for us to win if we stick is only 1/3, but the possibility for us to win if we switch is 2/3. You got it? All right, let's do a test and see if we really understand the logic or the mathematics behind the Monty Hall problem. Okay, so let's say we have 5 containers. We can also do 10, 20, 50, or 100. Same thing. So I just keep it shorter and make it easier, but I won't do 3 again. Okay, let's say we have 5 containers. 1, 2, 3, 4, 5. Okay, we know there's only one has treasure inside, and you randomly pick one. Okay, same thing. You randomly pick one, and I do you a favor and open the empty one from the left 4. Okay, so and I ask you whether you want to change, switch, or you want to stick. Just think about it. So if you can figure it out, that means you really understand the mathematics or the math behind the Monty Hall problem. Okay, before I tell you my solution, so pause the video and think about it and write a comment. You know, put your answer in the comment. So it's a test for you. Okay, 1, 2, 3. Okay, gotcha. So here's my solution. All right. So let's see. We still use the black box method. So the easiest way I use. Okay, let's say you pick this one. Okay. I use different colors. This is your choice, right? But we don't know which one has a treasure. We don't know which one has treasure. They are all black containers. Okay, and I put all the left 4s in the black box. Okay, they are all in the black box. You know, the dark. I can see it. I don't know what happened inside. I just put them in. Okay, now ask you one thing. What is the probability for you to win if you stick with your original choice? Because there are 5 containers originally, and you only picked one, right? You should see that I have 1/5. So what's the probability for this container, this black box to win? Because it has 4 inside, right? It should be 4/5. Correct? Yeah, it should be correct. Okay, now I do you one favor. Okay, I delete one. Okay, and open this one from it. What's the probability for this black box to win? 4/5. Let's see change, because you know in the first solution we already know that no matter we add in an empty container or we add in an empty container or we remove an empty container, it won't change the probability of this black box, because this black box is a black box. We treat it as a whole, correct? Now, if we stick with original choice, we have 1/5 of chance to win. If we switch, okay, we cannot choose the whole box. We can only choose one, right? So because there are only 3, we removed one. There are how many left? 3 left, right? Three containers left. So the probability should be evenly distributed. Okay, so the whole box, the whole black box, you know, the probability for the whole black box is 4/5. If we divide it by 3, the probability should be what? 4/15. Okay, that means the probability for each one, okay, for each one should be 4/15. Now, let's compare the probability. Okay, here is 1/5. Here is a 4/15. Which one is bigger? This is a stick. This is switch. Okay, this is comparable to what? This is comparable to 3/15. So the final result should be switch. We still need to switch. So switch is always the winner. Are you correct? I see you next time.